Hello, I'm Davina. Davina teaches biology. Today's video, I'm going to be making flashcards for the enzymes topic. You may have seen my previous video where I started these flashcards. Today I'm going to be continuing them, showing you that flashcards should be short. They don't have to be made up questions, but they do need to be accurate facts you can memorize word for word, so that when the exam question comes along, you are much more prepared. The first flashcard we're getting straight into. Factors affecting enzyme activity. We are going to list those factors. So, first factor on the list, enzyme concentration. Number 2, substrate concentration. Number 3, pH. Number 4, temperature. And number 5, inhibitors. So we have a simple list, which means when you are revising for a test, you say to anyone in your household, mum, dad, brother, sister, cousin, auntie, friend, on the bus, on the way to school, can you test me on my enzymes flashcards? They hold up the flashcard, not covering your face, and then you tell them the answers that are on the back. You have to get all of the answers right, and then this flashcard goes in the correct pile. If you get any wrong, the flashcard goes in the incorrect pile. If you are regularly testing yourself on your flashcards, you will remember more. But the flashcards are not to be made and then put away for 6 months. That's not going to help you at all. You make the flashcards and then you put a specific date and time when you're going to test yourself on those flashcards. Not just because teacher said I've got a test next week, as often as you realistically can. If you're doing an A-level in biology, you need to spend approximately 10 hours each week doing revision outside of school. So I'm not talking about the lessons you have in school. I mean outside of your lessons, 10 hours. That is if you're aiming for the A star and A grades. So be realistic. Are you putting in enough time to making your resources? If you are, then you will see the rewards. Our next flashcard. Explain how pH affects enzyme activity. So the flashcard I did before was just list the factors, but this one's going to be an explain question, so I need to give reasons. My first point, that is, enzymes have an optimum pH, keyword that you must include in your answers. And at the optimum pH, there will be the most enzyme substrate complexes. I'm sure you've seen that phrase on many mark schemes by now. Next point. At pHs below or above the optimum, bonds in the enzyme break. This causes the tertiary protein structure to change, and the active site changes shape. AS is short for active site. If the active site changes shape, the substrate is no longer complementary. Therefore, there will be fewer enzyme substrate complexes. Now, what's the key word we use for this? When the active site changes shape, the substrate can no longer bind as it's not complementary. Denatured. The enzyme denatures. So just to be clear, we can use this word denature if the pH is above or below the optimum. Here's my flashcard for how pH affects enzyme activity. You would then make similar flashcards for how enzyme concentration affects enzyme activity, how substrate concentration affects enzyme activity, how temperature affects enzyme activity. A common error with regards to temperature: when the temperature is below the optimum, you must talk about the enzyme and the substrate having less kinetic energy. Therefore, there are fewer successful collisions, fewer enzyme substrate complexes form, and the rate of reaction is lower. We do not talk about the enzyme being denatured at low temperatures. At temperatures above the optimum, yes, we use the word denature. Okay. Next flashcard. We have the inhibitors. We have competitive and non-competitive inhibitors. Competitive inhibitors, mode of action. This question is really common in exams. First point, the inhibitor molecule has a similar shape to the substrate, not the same shape, otherwise they would be the same molecule. But because the inhibitor has a similar shape to the substrate, the inhibitor binds to the active site. AS is short for active site. Now, if the inhibitor binds to the active site, the substrate cannot. The substrate cannot bind to the active site. It sounds like you're saying something very obvious, but we need to say the obvious. This means there will be fewer enzyme substrate complexes. Competitive inhibition can be overcome if we add more substrate. So if we increase the concentration of substrate, then the effect of the inhibitor is less, because now there's more chance that the substrate wins the race to enter the active site. So this type of inhibition can be overcome by increasing the substrate concentration. Competitive inhibitors, mode of action. If you're unsure about any of my shorthand, leave a comment and I will clarify for you. Non-competitive inhibitors, mode of action. In this card, the difference is we'll talk about the inhibitor not having a similar shape to the substrate, but binding to the allosteric site on the enzyme. This causes a change in the tertiary structure of the enzyme. The active site changes shape. The substrate cannot bind. There are fewer enzyme substrate complexes. Unlike competitive inhibition, adding more substrate does not reverse the inhibition because the shape of the active site has been altered, so adding more substrate has no effect, unfortunately. End product inhibition. I find a lot of students tell me they haven't learned this one at school, but you do need to know about end product inhibition. This means the product of an enzyme controlled series of reactions binds to an enzyme that is earlier on in the reaction pathway. For example, I'm going to write enzyme A, B, and C. These are controlling different reactions. But the product of the reaction from enzyme C is going to bind to enzyme A and stop enzyme A from working, a bit like a non-competitive inhibitor. The product from enzyme C binds to enzyme A and stops it from working. The advantage of this is that we don't get buildup of too much product because the product stops the reaction from happening. This is an example of negative feedback. We don't want buildup of too much product. That product could be toxic, it could be dangerous. So the product inhibits formation of itself. This is end product inhibition. For today, we'll finish, but I think I'll do another video to carry on with this topic because there's still a bit more. Temperature coefficient, cofactors, that will be in my next video. Please like and subscribe so that I'm able to keep this channel going and provide more videos to help you with your biology. Bye.